Okay, so we're going to keep talking about functional programming, and we're going to talk about a couple more challenging aspects of functional programming, at least tools that are used in functional programming. One of them is closures. We'll talk about closures, talk about currying, partial application, and then we're going to basically compare an object orientation design pattern with a way to implement it using functional programming. So let me share my screen. And yes. All right, cool. So we'll talk about closures first. So closures are a more advanced topic, kind of intermediate or advanced topic. So it's one of those things where if you don't get it the first time around, that's fine. So a closure is basically when a function returns another function and there's a local variable. So this, if we comment out, if we forget about this function right here, so this is returning a function, but this function counter has a local variable called count, right? It also returns another function, and this function accesses count. So this is normal, fine, good rules JavaScript. You can always access things in outer scopes, right? So I'm in here in the inner scope. I can always access things in the outer, and if count were a global variable, I could also access it from there. So there's no surprises there. The issue or the thing is that when you run this outer function, you might think that this inner value would disappear, right? Because this inner value belongs to this function, and we run it, and then once we run it, we return, and everything should go away, right? But what actually happens is that JavaScript still uses a closure to maintain a reference to this value if it's used inside of a function that it returns. So we can use closure to do a couple different things. One, we can use it to hide data. So in other object-oriented languages, not so much. I think JavaScript actually has private variables now, but I haven't actually tried that out myself. But let's just say Python and JavaScript don't really have private methods and data. But here is a way of essentially making this count variable private. So I can't directly access count, right? I can't access it from outside of this function. So there's no way that I can, in my code, do count equals, animal or whatever. It just doesn't work. So if I want to make this data private, then I can use a closure. So if I run this, I call this function, this outer function, counter, right? And I assign it to a variable. So now counter equals this function. But this function also has access to this variable. Even though this function is already run and returned, it still has access to this variable. So when I then run the function that this returns, I can access and change that variable. So we can run that. Let's see, cd. So I get 0, 1, 2. So its count starts at 0. So what I'd like to do is just to show, so there's something called garbage collection, which I don't understand in detail. But what it is basically is in lower level programming languages like C or something, for example, you have to specifically allocate and deallocate memory when you do stuff. So I want to do something, I want to allocate some memory, and then when I'm done, I deallocate. But here with JavaScript and Python, this you don't have to manually do that, which is nice for us. So there's kind of an automated process called garbage collection. And from my understanding, the basics are once nothing references a given value, then JavaScript will delete it. So the thing you would expect is that this would be garbage collected, right? I have a function exists in a particular environment. I, use that environment. I return, that environment goes away. All those variables should disappear, but it doesn't. Except, so let's go ahead and look at the debugger. So I'm gonna now uncomment this. So here's a variable here that's in this function, but I don't make reference to it in this inner function. So we'll see what happens to this unused versus the count. I'm gonna run the debugger. I'm gonna keep track of, and I'll add one. Okay, so right now, yeah, that's fine. Those don't exist yet, so we'll, I should probably start, we'll start here, it's fine. Okay, so count exists and unused does not exist. So let me start from, we'll start from here. We can do that again. So when I run it, I have access to this. I run this, count changes, unused is still, there's a reference error. So this function somehow knows about count, but even though unused is in the same scope as count, it doesn't know anything about it. And that's because this has been garbage collected. But JavaScript made a special exception for count because this is a closure. All right, so that's closures. It's one of those more intermediate concepts. So take another gander at closure at some point in the future. All right, so let's see what else we got. We got partial application and currying. Okay, so I'm going to keep sharing the screen. And let's look at an example of currying. So this is a function. This may look like gibberish. Like, how does this even work? So partial application and currying are basically the same thing. Currying is restricted to single parameters. So I have a function and I apply one parameter at a time. That's the basic idea. Okay, so why would you want to do this? This is just ridiculous. If I want to add three numbers together, I'll just pass in three numbers and add them together. Why would I go through all this nonsense of adding extra steps? Well, one reason would be code reuse, for example. So I have a very general function that adds three numbers, right? But let's say in my application, I am just constantly adding 5 to stuff. So this is just a regular feature of my application. So now I can create this add 5 function. And add 5 is always going to be there. It's easy to see what it does. I know what it means, and I can reuse it over and over and over again. I don't have to specifically write my own function. I have to call this function with new parameters every time. So it's a way of reducing repetition, right? So that's one benefit of this. So if we call add 5, we can call it with 2 and whatever, 10. And I'll console log this. Wrong file. I get 17, right? 5 and 2 and 10. So I have 5. It's already, that value is just locked and loaded. It's ready to go. And then I can call it twice more with whatever I want. Let's say another common thing that I do is I add 100 to stuff, right? So I'm always adding 5 to stuff and adding 100 to stuff. So I can create another function and specifically name it. So now if I want to add 5 and 100, I can call add 5, add 100, and something like 2. That is wrong. So this will give me another function. And then if I call that function, oh, it's outside the console log. What are we doing? I'm passing in a function. I think I'm gonna have to do add 102. Sorry, this is obviously not something I do often. Function. Now I'm actually confused myself. Let me check my notes.
Can't you just add empty parentheses at the end to invoke it?
Let's see, I've got a function call. Yeah, I need to pass a parameter when I'm calling it.
Would you have to put add 100 into in parentheses after add 5? Like
Yeah, so I've got add 5, and I'm passing in the value from add to, I think I've already tried this, but
I meant outside of the purple curly brace, but still within the console.log.
yeah, I'm just gonna have to cheat and look at my notes here. So n15 val add 15. Okay, so we'll assign it to a new variable. So we'll do add 105 equals add 5 let's see 100 yeah. Yeah, so anyway, currying, that's currying for you. So not the most intuitive process and not something that I do frequently. So we'll move on from currying, and we're going to talk about we're going to talk about design patterns, but when you start looking into object orientation, people talk about design patterns. And there's all kinds of different design patterns. Not all of it is directly applicable to Python or JavaScript. This is, they're mostly, when they talk about design patterns, talking about, C++ and Java and things like that. But a lot of this stuff is applicable. So one kind of the simplest design pattern is something called a singleton. And that's where you have a class, but you only want to create a single instance of the class. So why would you ever want to do that? What's the point of creating a class if you only are creating one of them? Why not just create an object? So that's a great question. But the use case for something like that is usually, so I've used it in application for handling credentials. So you have internal components and they need to talk to each other and they need to have valid credentials. So you create a class that handles that, and you don't want 50 different copies of your credential class floating around. So you just make one of them. So let's look at, okay, so we'll make an example of a singleton in Python. So we have something called the credential manager, right? So we want our credentials to be just in one place, only create one instance of this class. So what we're basically gonna have to do is when we try to create an instance of the class, we're gonna need to check if one already exists. And if it does, then we just return that instance. And if it doesn't, then we create that initial instance. So that's it. So there's a way of doing that in Python. We've seen the init dunder underscore method. So when Python creates an instance of an object, it actually runs through, there's a whole bunch of hooks. So we'll look at hooks when we talk about React, but you can basically think of them as lifecycle hooks. So as this instance is being created, it runs through a whole bunch of different things, and you can hook into those stages and modify things. So one way to do this here is so you've seen the init dunder. So you can do something like that, and notice you don't really need to know this. I'm just kind of exposing you to it. So new will take a class. It doesn't take self, doesn't take an instance. And then what we're going to do is,
are you sorry, are you screen sharing?
Oh
Yeah, I was in a second.
Thank you. Sorry. All right. So now you guys can see my screen.
Yeah.
Cool. Yep. Okay, cool. All right. So we've got a new class, and what we're going to do is we're going to create something here called all right. So we have an instance here, and what we're going to do is we're going to call the super classes an instance or new. So super dot new. We're going to pass in. Oh, this should be fine. So if let's see, cls.inst, something like that. Okay, so we can try to create an instance. So C equals and then I'll save that and try to run it. So So we have an instance of an object, and we'll just try to create another one and run it again. And this may not be entirely obvious initially, but this gives us the memory address. So we can tell that these are the same. Actually, they're not the same. Let's do. Okay, so instance is none. We try adding. Requires if is none. Let's see. Give me 1 sec here.
Hey, Chad,
Yeah.
do you need to assign instance when you create it on line 5? So you call skipper underscore new. Do you need to assign that to whatever that returns, assign it to instance so instance gets initialized?
It should, super should just automatically take the class.
Right. So you're creating a new object and returning it at line 5, but don't you want to assign that object to instance? So the class.instance value?
Oh, yes, thank you.
Yeah, so I think it's just creating 2 new objects because we never get instance.
Thank you.
We still got to return it, but
Yeah, okay. Thank you. Okay, so now that actually works. Thank you very much. So we have the same memory address. So we're trying to create, so as many times now as we try to create this instance, it's always going to return us the original one that we created. So there are ways of doing something similar with functions, right? So we saw with closures that we can kind of create a little wrapper that has a local environment, and we can modify what's in there without being able to change it from the outside. So we can go ahead and we'll look at another JavaScript library. We change the share. Okay. So we're going to go to back to npm.js, and we'll look at something called, well, we can do a search for functional programming, but something called Lodash, which is very popular for, it's a functional programming library. Oops, and I'm not sharing. So this is a functional programming library, npm.js, search for Lodash, and we can see that it's got 42 million weekly downloads and a whole bunch of stuff. So if you can take a look at their GitHub repository, and they have a whole bunch of, maybe we should go to the, actually we'll go to their webpage. Okay, so Lodash Modern JavaScript Utility Library for delivering modularity. So this is a functional library that you can use in JavaScript. We'll go to the documentation and we'll search for once. So once is a function. So Lodash is kind of the library. This is the convention for using the library. So Lodash.once. And once is a function that takes a function, right? Like all functional programming, it's a function that takes a function, creates a function that is restricted to invoking the function once. Repeat calls of the function return the value of the first invocation. The func is invoked with the this binding and so on. So I can use once to make sure that I'm only running whatever function I pass at once. So let's see if we can, let's take a look and see if we can, we'll see if we can implement it first, and then we'll look at the source code and see how we did. So function once, and it'll take a function and it's going to return something like this. We could do, yeah, so I mean, there are a couple different things we could do here in terms of passing the parameters. Let's do function, and then our return will be an arrow function. In case we have parameters, we can make this kind of general purpose. And then we'll return return all right. So we have a function called once. So far, it doesn't really do anything, but it takes in a function. I can grab all the arguments from that function and then call the function with those arguments. Okay, so this doesn't really do anything other than just call the function. But we can use closures to add some, add a condition. So let trigger equal true, or true equal true. And then when we call the function, we can do we'll just do false. If our trigger is true, which means we haven't run it yet, then we will return the function. We'll call the function and return it. Otherwise, well, we can return something like that. Okay, so let's try using it. Let's test it and see if it works. So we'll do let's do +2. Okay, so this is the function I want to pass in, and I will call once func equals my func. And then I will go ahead and call it. So once func, I'll call it with 4. Thing. So cd Singleton. So this returns a function. So if I can try calling it again, this returns null. True is true, return args. Let's see.
Do you need a parameter down on the bottom when you set it equal to my func. Once you have the once my func, do you need a parameter in there or no?
I shouldn't need a parameter there. Let's see. Return.
Is
Let
the-
me call the, let me try this.
Is the trigger equal false just automatically negating like that if statement right after? Like, is that never gonna run if that trigger's right there? Like trigger equals false is right above it. every time?
Yeah, what am I doing? So, right, okay, so I'll need to do trigger equals something like, yeah, so I'll call that, thank you. Okay, so we got to 6 now. Okay, so we have a function once. Thank you for the help. So we've got a function once. We have a trigger. So this is now part of the closure, and we're returning a function call basically with the arguments that we passed. So we have our function here. So let's try running this again. So we'll just go ahead and return null. Okay, and it doesn't matter how many times we call this after. It's just going to return null.
I have
So, yeah.
In let res equal func of the arg, and then it takes args. Where does func get defined?
So this is what we're passing in. So that comes from here. So yeah, as you may have noticed, this stuff can be kind of confusing, especially when you don't do it on a regular basis. It's lots of functions doing lots of things.
I'm a
But
little
yeah.
bit confused on what are you trying to show with this code?
That you can create a function that will add additional logic. So I'm wrapping whatever function I have, whatever this could be anything. I can now make sure that I only run this code once. So in Python, we'll see something similar. The syntax will be a little bit different, but it's called a decorator. So I can decorate, or I can modify how a function executes by passing it into another function. I could even do things like modify the parameters before I pass it in. You can do all kinds of things. So let's go ahead and look at the source code for. So we have Lodash. We're using, actually we didn't actually use it. So let's go ahead and try using it. So we'll go through the same process we did before with Jest. We'll do npm init and get a project started. So npm -y, and we'll do npm install. We'll install Lodash. Okay, cool. So now Lodash is installed. So I can try. If I look at the docs real quick. Installation, something, save. So we'll do this. We go to documentation, we see get a basic usage. Okay, so now this underscore is going to refer to the Lodash library. I'm going to go back up here and look for once. I'm going to once, and you can see the usage is pretty simple. So we'll just do that. We'll pass it a function, and we'll pass it this thing. Well, actually, let's just pass it a print statement. So I'll run it. Oh, whoops. Do node.js. So that looks like that ran. This is a function. So we'll try doing so it runs, actually, yeah, we're not returning anything, so I don't need the console log. But here so now we're using the same function. So we built our own custom once function. Now we're importing something from, a library where people know what they're doing. And looks like we can run it once. Let's see if we can run it twice. Nope, it just ran once, right? So we called it twice, it only ran once. We get the same functionality. Let's try running it 3 times, still only runs once. All right, so that looks like it's working. It's like, so we just went to there, we went to NPM, we found this library we wanted to use, we did NPM install, we installed it locally on our computer, and then we looked through the documentation and found something that we wanted to use. Now we'll go to their GitHub page. We'll look quickly at their source code. So I'm going to do once. Here's where once lives, and you can see that there's one file here, and it's got one function. So this is nice and modular. It's a huge doc string. Tells you the parameters that it takes. Takes a function. The function is to restrict. The function to restrict returns a function, right? And what's happening here? So this is once, this is the source code, and it actually just returns another function that they built somewhere else. So this is basically an alias for another function, but with a specific parameter. So let's take a look at before. So you scroll up to before. There we go. So once calls before with 2, and if we go here to before, we can see something similar. So it takes the number of times it can run before it doesn't run anymore, right? So if you only want it to run twice, you give it 2. So it runs once, and the second time it doesn't. You give it a function, just like ours. So this is just some error checking, so making sure that you're giving it a function. Then this is returning a function with the arguments. It's decrementing n and checking if it's greater than 0. And if it is, then it will return the function. And if it's not, then it returns undefined. So not that you'll really be needing to go into source code. Most of the time it's not helpful, but it's good to see kind of, this stuff exists. You can actually go look at it. It may not answer your question, but it is there, and most of the time it's pretty easy to access. All right, so I think we should take another